Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit multiple integrals. And this is our assignment number 4. So in this video, we're going to work on several problems in the assignment number 4 worksheets. And these worksheets, we talk about how to calculate the surface areas here. Okay, so let's go ahead and take a look at our worksheets, and then we can start to work on some of the problems here, Okay, so this is our worksheets here. Okay, so the first ones here, let's take a look at the problem number 2. So we want to find the part of the plane 2x plus 5y plus z lies inside a cylinder x squared plus y squared equal to 9 here. Okay, so we want to find the plane. Okay, so in here, so remember the surface area of the surface area is, what do we say here? Is we say is you integrate over these regions, right? So you integrate, let's say here, maybe probably it's better. We put these ones here. So we say we over integrate these regions, and what is here is 1 plus f of the x squared and f of the y squared, and then the dx here. Okay, so now let's take a look here. So here, the z, all right, so the z is equal to what? Is 10 minus 2x minus 5y, right? So the partial for x is equal to what? Is negative 2. And the partial for y is what? Negative 5, right? So I know now I can say that my surface area, I can write it as this area. And then here, this is 1 plus partial x, the square, and partial y, the squares here, right? Okay, so then this is my d areas here. And then this areas here is x squared plus y equal to 9 here, right? So this is x squared plus y equal to 9. And in here, this is just constants, right? So this is 30 and the dA. So you can take the 30 out. So in here, this is x squared plus y equal to 9, the dA. So I know this is the area. This is a circles, right? So this is a circle with radius. This is 3. And this formula here, because I don't have a, so basically by the double integrals here, so this is really, I just do once, right? So now what I'm looking for here, I'm looking for is the area of your integration region. So what is the area? So this is a circle. So the area for the circle is pi r squared. So what is the r's here? R is 3, so it's 9 pi's, right? So now I know my answer for here. So my surface area will just be 9 pi and the square root of the 30. Okay, so this one is pretty straightforward. Okay, now let's take a look at the other ones here. So the other ones here, I'm looking for the surface area above the triangle has the vertices is 0, 0, 0, 1, 2, 1. So, okay, 0, 0 is here, 0, 1 is here, 2, 1 is here. Okay, so basically I'm looking for, this is my integration regions, right? Okay, so if this is my integration regions, then the problem will become pretty easy. So let's see here. So what is the, we can say the partial x. So what is the partial x here? Will be 3, right? Then partial y, so the x be constant. What is partial y's here? Is 4y's, right? Then I know the surface area will just be, you integrate over this region, we call this d's, right? And then the square roots of the 1 plus the partial x squared plus the partial y squared, the d's, right? Okay, so now if you simplify this a little bit, and then this is outer D regions here. 3 squared is 9, so it's 10 plus what? 16 y squared, right? So the dA is here. Okay, so now for this ones here, we need to decide I want to do the dx or dy first, right? You know, we see this integration, this is 10 plus 16 y squared inside the square roots. So probably I will do the dx first. So I don't need to worry about this. So I said the dx, dy here. Okay, so now the dx, that means I am going to integrate into the x directions, right? So x direction is from 0 to this line. So what is this line here? This is the slope is rise over run, so 1/2, right? So y equal to the 1/2 of x. So what is x here? X equal to 2y. So when I integrate the x here, so I will integrate 0 to what? 2y here. Now, in here, I have dy here. The y will be what? 0 to 1. So you will see when we do this, it turns out we made the right decision because after you do that, so this is 0, 1. So this will be this is 10 plus 16y squares, right? And then the x will just by itself. So this is the x, and then you have the lower and the upper bounds here, and then the dy. And so you will have a 0, 1. So what you're going to have here, so you will have a 2y, and then this is 10 plus 16y squared, and dy here. So after you see this, then you know this is a good decision. Why? Because in here we can do u sub, right? Then we'll be able to integrate that. That's cool. So we can say the u is equal to the 10 plus 16y squared. Then the du is 32y dy. And then you can, so in here, I already have a 2y dy's, right? So then you can say this is du over what, 16. This is a 2y dy's here. Then you do a u sub. And so like in here, like I said, I'm not going to kind of focus on the integration. Assume you can do that. So after you do the u sub, and then you will get this is what we have here is 1 over 2 times 1 over 32 times the 2/3, and then this is 10 plus 16y squared and 3/2. Then it's 0 and 1 here, right? So if you like, you substitute put it into the calculator, and this will give you what? This will give you like it's 1 over 24. So then this is 26 to 3/2 minus 10 to 3/2. So here, if you want, you can put in the calculator to get some decimal point, but it's not necessary here. Okay, so now the other problems we're going to do, this will be the last problems here. Okay, so oh no, I think we missed one here. Okay, yeah, I want to do this ones here. The part of the surface z equal to the xy lies within the cylinder x squared plus y squared equal to 1. Okay, so the same way we do the partial x is y, partial y is x here, right? So now I know the surface area will just be what? Will just be d, and the next 1 plus x squared plus y squared, and the dA here. And my integration region is x squared plus y squared. So what is that? That is what? That is a circle, right? So it's 1 and 1. So I know I can change to because this is a circle. So this is a circular integration region. So I know I can change to the polar. Maybe it will make it easier. Let's take a look. X squared plus y squared is what? It's 1 plus what? R squared. And when you change it to the polar, don't forget, you need to do what? You need to do the Jacobians, right? And now I need to integrate the dr and the d thetas here. So see how easy the integration become. The r will be from where to where? From 0 to 1. Because this is the whole circle, so the theta is from what? From the 0 to where? 2 pi. And then in here, you see here, it's beautiful, right? So this is 1 plus r squared. You have a r outside. So what do you do here? You use u sub, right? So you will say the 1 plus r squared is equal to u. Then you can do the u sub, and then you will be able to integrate. So here, these ones, after you integrate, this will be the 1/3. And this is the what? This is the r squared plus 1, and this is 3/2, right? And then the r from 0 to 1, I have a d theta. And now, after that, and then you will have 0 to the 2 pi. And then this will be 1/3 if you plug in here. So you will get a 2 of the square root of the 2 minus 1 d theta. And this is all constants. So the d theta is 2 pi, right? So the answer is 2 pi over 3, 2 square roots of 2 minus 1. Yeah. Okay, so that's a pretty easy. So the purpose for this problem is just said, hey, after you set up, then you use the polar will simplify the calculation. Okay, so now let's take a look here. I want to find the part of the sphere x squared plus y squared plus z squared to 4z lies inside the paraboid z equal to the x squared plus y squared here, okay? So in here, you will see here, right? So z equal to the x squared plus y squared here, correct? Okay, so now this part, take a look at this part. This is x squared plus y squared. This is z, right? So I can solve it. So I will say z plus z squared equal to 4z. Right? Okay, so now you will have z squared minus 3z equal to 0. So I will have z and z minus 3 equal to 0. So I have z equal to 0 and z equal to 3. So they are the planes, right? So those are the planes where the surface intersect, correct? Okay. Okay, and okay, so we know here also like in here, so we have x squared plus y squared plus z squared, okay, equal to 4z's, right? And I move the 4z's here is equal to 0. So I can say this is x squared plus y squared plus I completed the square, the z minus 2 squared equal to 4. Okay, so okay, so I know the z equal to 3, right? And this is what? This is a sphere, right? So it's added 0, 0, 2, and the radius is 2. So I know what? So I know z equal to 3 intersect at the what? And the up hemisphere, correct? Okay, so now I know the here, so I can rewrite this ones here. So I will say the z minus 2. Okay, so I will say the z minus 2 square is equal to the 4 minus x square minus y square. So I can say z is equal to the square roots of, okay, so here, be careful. So the z minus 2 equal to the square roots, right? Okay, so that's why I can say z is equal to the 2 plus square roots of 4 minus x squared minus y squared here. Okay, so that's why I know, so the area, so we can therefore we find our area D, okay, is the region. Where is this region? It's the region inside the circle. Okay, x squared plus y squared plus 3 minus 2 squared is equal to 4. So that's why I know my regions here will be xy. So what type of the regions here? It will be x squared plus y squared less than equal to 3. So it's a circles here. Okay, so now finally, right? So now we can, because in here I have z, I already derived the z is equal to the 2 plus 4 minus x squared and minus y squared, the square roots. Okay, so now let's see the f of x. Okay, the f of x, what is the f of x here will be? F of x will be the 1/2, right? So this is a 4 minus x squared minus y squared, negative 1/2, negative 2x, it's correct? And the f of y is the same thing, so it's 1/2, 4 minus x squared minus y squared, negative 1/2, negative 2y. Okay, so now I can find the surface area and do this D, and so this will be pretty kind of the, okay, so here this will be, this is 2 and 2 can cancel, and the fx squared. So what is the f of x squared here? So it will be x squared, and here is 4 minus x squared minus y squared plus y squared, right? Then the bottom here, this is 4 minus x squared minus y squared plus 1, the d8. Okay, so this looks pretty complicated. Also, we know the integration regions is circles here. So probably let's try to change to the polar to see how simplified we can get. Okay, so here, okay, so this one's here, right? X squared plus y squared. So basically, this will be 4 minus what? 4 minus r squared. X squared plus y squared is r squared, right? And plus 1. And of course, this is inside the parenthesis. And then don't forget to times what? To times r, right? Then you have dr d theta. Okay, so because I'm integrating over this circle, so what is the r's here will be? And so the r's here will be from 0 to the square root of the 3 and to where? Okay, so then to the thetas, right? So the theta is 0 to where? To the 2 pi's here. Okay, all right. So now let's take a look. So the integrations here, it will be, so if you simplify the inside a little bit, okay. So if you simplify the inside a little bit, and then you can get a pretty cool. So this is the square root of the 3. So the inside, if you simplify that, and you will get is 2r, and this is 4 minus r squared. Then, you know, you have dr d theta, right? Dr d theta. So if you, okay, so now this is cool again because you have, this is 4 minus r and you have 2r. So what you can do here, you can do another u sub, right? So you can say u equal to the 4 minus r squared. Then you will be able to take the integration of this one here, okay? So now finally, we can get here. Let's assume you know how to do the integrations here. So this one will give you -2, 4 minus r squared, 1/2. And then the r is from the square root of the 3 to the 2. All right, then here is d theta. So amazingly, so this one's here, after you substitute here, this is 0 to pi, and you will get this is -2 plus 4 d theta. So it's 2 d theta. So this will be the 2 theta 0 to the 2 pi. Whoa. It's such a beautiful answers, right? So the answers here is 4 pi's here. Okay. Okay, so so for these sections here, really is not too hard. Basically, we depend on that one formula, the surface area formulas, right? Then the only thing you need to be careful is how to find the integration region, and then when you do the integrations, and maybe you need to consider by using the polar coordinates to simplify your integrations here. Okay, so I did these 4 problems, and hope that these 4 problems are helpful for you try to finish the remaining the problems in this assignment. Okay, that's it. Have a good day, and I'm looking forward to talk to you about the triple integration, and let's try to do some problem on the triple integrations. Okay, that's it. Have a good day. Bye.